Okay guys, so I hope this is visible to both online and offline. So let's start with the today's topic, that is support vector machines, SVM. See, one of the major thing to know between why SVM and why this is needed. This is one of the algorithm which you can use both for the regression as well as for the classification task. Right, the first novelty you can get into this is you can use it for regression as well as for classification. Right, so we'll be starting with okay, my pen is working. Yes, working. So SVM is nothing but support vector machines. Alright, first of all you should write the formula. It's not formula, full form. Support vector machines. Right. So we'll starting with the one by one topic. That is, first one is introduction. So as I told you guys, this is one of the algorithm which is used for both regression, classification. Right. And I hope everybody is making notes. Okay. Then another key feature of SVM, whenever you have binary data set, binary classification, like is in yes, no, true, false, having heart disease, not having heart disease classification problem. When it is binary, that is in two class problem. At that time, it gives you very good accuracy, very good accuracy, very good accuracy. Right. Third part is there is one concept of hyperlink. Okay, you can correlate this with linear regression. When we are talking about linear regression, no, at a similar time, it is nearly same concept. I'll talk about this right now. Okay, give me 1 minute. So it finds the best boundary. It finds the best boundary that separates, like best fit line was there, no, with same boundary, separates data point of different class. Different classes. Okay, so there is one term known as hyperlink. We'll come to know about this, but the basic part is it finds the boundary point, that one boundary which perfectly divides or perfectly separates two of the classes, right? So okay, any doubt till here about SVM? Again, it is used for, this is supervised machine learning algorithm. Whatever we have talked till now is a supervised machine learning algorithm, right? You can ask me why to use SVM. Before going why, let's talk about what is SVM. Then we will talk about why. Okay, for what now? See, in the linear regression, what we have, something like this. We are having Control C, Control V, Control V. 4 is fine. So I'll select this one, put next to this. Select this one, put next to this. Yeah, by the way guys, we are gonna start DSA problem. Okay, in DSA, lead code problem. So if you are interested in lead code, you can join our DSA course. Okay, and I'm gonna teach the lead code problems. So if you are interested, you can join. Not a compulsory. Huh. So in the linear regression, sorry, I have to check. That is hyperlink, right? You wrote hyperlink. Okay, sorry. Plane, hyperplane, sorry. Hyperplane. Hmm. We'll talk about what is hyperplane and everything. So what happens now in linear regression? Some one of the data points might look like this to you, and some of the data point might look like this to you. Okay. So let's say these are the negative data points, and these are the positive data points, or vice versa. You can take anything. Over here, as you can do one thing, the best fit line in linear regression, what we do, we try to plot a best fit line which divides the in the best manner the classes, right? And sorry. So just a second. For this, we are gonna to plot this. This is known as hyperplane. Hyperplane. But there is a difference. We go for the margins. What we go for the margin between the classes. Means what I want trying to say is, just a second, I'll draw. Is there any dash line? Type of line. Okay. One line extra. This is known as margin. Margin goes from the nearest point of the particular class, right? So let's say we'll make this as blue, some orange. Okay, and one more margin line from here, which goes from the outermost, the nearest one, to the hyperplane. Sorry, why I'm saying hyperplane? I don't. Alright. So this one is the nearest one. As you can see, this one is the nearest one, and for this is the nearest one to this hyperplane, right? So it can be more than one. If multiple points are there on this, it is also possible. For example, in this case, the positive case, this is possible. So why we find margin? To separate most of the class, to reduce the standard deviation. Okay, and why it works more better? See, we'll get one more example. We'll go with one more example, and you will be able to understand very easily. Over here, if you want to draw a hyperplane, your hyperplane will look like this, right? Something like this. And what about the margins, brother? If you are talking about the margins, we'll use this, we'll put margin. So the margin will be very close to this, not as far as the other one is. Okay. See, there are very less margin, right, brother? So this will why this margin matters. The maximum the distance between margin and the hyperplane, the more better you model able to evaluate the difference between the classes. So what does it do? This SVM gives you two extra margins. These are known as margins. This and this margin for both of the classes here also, and try to maximize this distance. What is the maximum possible distance? We'll go with that mathematical term also, but it tries to identify the maximum for the first basic thing. Now, as the distance is less, there is a high chances of model to predict less, less accurately. Right. So the more the margin, the distance margin, the more the better accuracy. Right. So, and hyperplane is nothing but a distinguished line, like a best fit line, as of our in linear regression. But okay. Now going to the next part. See, hyperplane is a line. You can write it over here. Hyperplane is a line when we are talking about 2D. Right, this is a two-dimensional vector. We are talking about two features, somewhere and somewhere this, somewhere and somewhere this. Now once you started talking about three feature, it will become a three-dimensional, right? So this line will now become a plane. This hyperplane will become a plane, right? So hyperplane is a line in 2D and is a plane in 3D, right? SVM tries to find the hyperlink that best separates the data into different classes. Okay, so this is one class, negative class, one class, positive class. So that is the work of SVM, to find the best hyperlane which separates the data in the best manner possible, right? And the margin, again, the distance between the hyperlane and the closest data point. This is the closest data point to the hyperlane. This distance you can call it as margin, right? And the line also you can call it margin. As one more point, SVM seeks to increase as much as possible the margin. SVM seeks as much as possible for it tries to maximize margin. For what? For better accuracy, better classification, not accuracy, classification, right? Then we can come to something known as support vectors. Hold on tight. I'll go once again on all the topics, so don't need not to worry. Okay. Support vectors. Support vectors are nothing but the data points which are lying on the margin point, which are margin point or which are closest to the hyperplane, right? So this point is already close, that's why it is lying on the margin line. So you can call these are the point as support vectors. Which one I am talking about? This, and over here I am talking about this. These are the support vectors, which are very close to the hyperplane, right? So you can write that support vectors are nothing but the data points that lie closest to the hyperplane. Okay, so this is one thing. Then why we call it support vectors? Okay, vectors we can understand, we are talking in the direction of something, but why support vectors? Support, because these two points these points support or helps in defining the position of the hyperplane, right? The basic English I am talking, hyperplane, not plane, hyperplane, right? Any doubt till here, guys? Any kind of doubt till here? Any kind of, huh? See, हाँ तुम्हारा क्वेश्चन मैं okay, I'll answer in English only. The question is if we are talking about the vector accuracy to increase this distance. एक सेकंड, यस, ये सामने वाला, उसका वो नाप आप देख लीजिए. Sorry guys, actually I can't do anything in this. हाँ, so what we are talking about, your question was when we want the highest accuracy, so why we are taking the closest point? Because this line, if you draw the SVM over here, let's say these two are the points, and you go with this and you go with this, right? And this is your hyperplane, right? The more the distance is, that is margin, the better your accuracy. How? Reason being, the model is more able to classify. See, this is also a distance. Over here also the data points are not overlapping. But how the more the distance, the more the result. Reason being, you can see that there might be a disturbance. Over here the distance between this and this are less as compared to this and this, right? So model can easily recognize, as you can think like of separating sand and rice, right? If you have mixed it properly in between, it is very difficult to figure out each and everything, because when you are gonna pick a single rice, then at time you will pick sand also. So the more the distance, let's say two bowl are there at a some distance, the more the difference, the more able to categorize. It's more likely this. Else, if you reduce the distance, or if you are talking about the more this one and this one, if you talk about the last vectors, last point, so the point is ki support vector means no, this margin is mainly for the disturbance. Disturbance in the sense that there is nothing in between this. This is the distance. But if you talk about this and this, you are getting all the points inside it. So the model is not able to understand what you are talking about. The model knows that this above this line is one thing, that is positive thing, and beyond this line, these are negative thing. Have you read in class 12 something ki after this line, whatever thing is positive, before this line, everything is negative, something like that? So the more the distance, the more easy to understand ki where the actually point starts from. Then it comes to the point of hypothesis, not hypothesis, sorry, this formulation part. Once you talk about the formula of, I don't want it to go in a support vector machine formula, because then we will talk about transport of x plus p, y is like this. So what happens now? Whatever the point you are having, from this point to the line, first of all you have this point and this line, right? So you have to check for the transpose, then multiply it, and you will get a y vector. Okay, a y vector or y you can call it, not a big issue. So y vector, once you are getting a y vector, then you have to talk about the distance, and how is the distance proportional to this, where the point is lying on. Is the point is positive or negative, right? So that will create a too much of mess. Most of the things you guys don't know right now, because to understand support vector machine, you should know logistic regression. I want the basics algorithm to be clear at a basic level. So right now just understand that there are two lines which we want to best fit, and we don't want anything in between like this. Think of like we are planning to have a prime minister convoy over here, and as much as far the public can be possible, like distance can be possible, we will try to make it. Right, to maintain the security. That's what the best fit line and this margin comes. Did you got my point? Zebran. See, if you take the outer points also, no, then there will be confusion in the model. For model, what we are trying to do in logistic regression, or if you do about basic classification, what we are trying to do, we are talking about one category over here, another category. The more the distance, the more thing. For a moment, you can understand there is nothing in between this. So now you can understand that this is a one line equation going on. So everything beyond this line is type of one category, is one class. And apart from this another line at second margin, so everything beyond this line is your another class, second class. You got the point. Somebody mic is unmute. That's why to make the model be calm like saint, we use this key. Okay, in this nothing will be given. Like I am adding some extra stuff like saint and all. This is nowhere written, but to understand I am talking about like this. You got the point now? Somebody's mic is unmute. Everybody got this concept? If you have any doubt, just raise your hand. We call it marginal distance. Actually, the exact term for this is, I just remember, these are margin. These all are margin. This and this. The distance is known as marginal distance. Distance. Right. Any doubt till here? The more the distance, the more the. For example, if you are talking about in the x time, this positive one, this cross one, this distance, and the more the distance, the more better the result able to identify the classes. See, you can understand like this way also. One more example I got. See, one neighbor, and see, this is your house, and this is your neighbor house. Now you have to identify as another person. Let's say I have to identify your and your neighbor house. For me, it's now more easy. I can say this is your house as compared to your neighbor house. But if the same case arises like this is your house and this is your neighbor house, I'll be okay. This one was most probably this one. But if your house and your neighbor house having the same boundary, then there will be a high chance of me getting confused, the first one or the second one. That's why we maintain as much as marginal distance. You can understand, like you can call this term as marginal distance. And a line which is deciding that this side is your house, this side is neighbor's house, is your hyperplane. Did you understand the concept? So as the if it is linearly separable, this is the way. If you can draw a line and you can separate two of the classes, then we can call it as linearly separable. Linearly separable. Right. And if in case your data side might look like this. And if you try to fit a line in between like this, something or something like this way, now you can see, let's talk about one by one. Here you can find that your model will be having accuracy less than 50%. Right, because you are not able to find this pattern. This is also coming in one side and another part is also coming. So what your model will do, will try to tukka nahi kehte, try to predict on without any hypothesis. It will try to predict. You understand the point? If it is separable by a line, then we call it as linearly separable. If your classes are separable by a line. If it is not, so what we'll do, we'll try to visualize this problem into two-dimensional. Right? So how it will look like if you try to talk about this in two-dimensional. Put one more dimension over here, no? Right, not like this. Actually, I have one more better option. Click on insert, click on 3 dimension. But we know OneNote never support us, so no issues. So let's say this is a 3-dimensional line, right? And we took a pen blue color. If you are putting your line, so x, right? This is a very bad graph to explain it, so I'll take my own. Now if this is a 2-dimensional, if you try to put one more dimension, this is a 3-dimensional, right? Z-axis. This was your x, this was your y. If you're trying to put out of this z-axis, now you can see this. If you try to visualize it, your classes will be either shifted up and the down, like the red one at the top or black one at the top, or vice versa, right? Or you might get a curve, something like which might look like this. This is the graph. So your data might look like this, and this. And if you do the projection from the top, no, in tool plane, you will get the same thing. Are you guys getting my point? Think of like this, no? Means ke, think of like if you are having two disks, one below another, concentric circle, like over here, if you're talking about 2D, it's concentric circle, one inside another. But if you think like one is the circle above another circle and you are talking about top view. So if you talk about top view, you will see in 2-dimensional. If you talk about from the 45-degree or from the eye view, you will see in 3-dimensional. Are you getting my point? Like this as the first one and the red one below it. Something like this, and in 3-dimension. Now this is one of the better example. Think of like a chain, no? 3-dimensional chain. Now you understood. So whenever you don't have any linearly separable data set, at that time what you have to do, you have to increase the dimension. Okay, increase the 2-dimensional to 3-dimensional, you're able to find. And over here you can create, give a plane at some xyz value, so this will be a plane which can separate both of them. The black one and the red one. That's why we call a plane, hyperplane as a plane in 3 dimensional and as a line in 2 dimensional. You guys got the point? Did you guys understood SVM? Okay, better, better, better. So there is known as kernel. I'm not talking about mathematical. Theoretical we are going, because this mathematical you can guys get little bit of confusing also. Although, but okay. Just a second now. Just. It's fine. Leave it. It's fine. So what we were talking about, kernel. Something is known as kernel. Whenever you might see multiple times, it's not about a straight line, right? Always you will be having a straight line or a flat one another. Multiple time it can be your curve. We talked about, no? It can be curve like this. Means the same thing, but in some this way, in 3 dimensional, right? So to deal with this, we have a kernel. Okay, like SVM supports a kernel, which allow us to operate in a higher dimensional space without explicitly computing the coordinates of the data in the space. See, this is the bookish language, what I have just spoke, read. Kernel, I am writing, if you want also to write, you can write, allows SVM to operate in where it went, hide a higher dimensional space without explicitly computing the coordinates of the data in the space. See, what it is trying to say, ki when you are having a curve or some high dimensional data which is not linearly separable or not in a particular plane or something, so at that time we need, if you have curve or something in your data set, at that time we need kernel. What kernel will help and how? The point is ki it will allow you to do everything, like to count the coordinates of the data, but without explicitly computing it. Bole to you don't have to explicitly count ki, okay, what is this curve and how this is passing, and what about this line, what about this curve, for which line it will be passing. So it allows SVM to operate in high dimensional space, let's say with 3 dimensional or 4 dimensional, without explicitly computing the coordinates. Without explicitly computing iska coordinate kya hai, iska coordinate kya hai. Coordinate is nothing but x comma y comma z, that is coordinates of the data in the space. So whatever your data have inside your 3 dimensional or 2 dimensional space, you don't have to find explicitly the main coordinates, right? That's where how kernel allow us. Some of the common kernel, see again I am going with the notes, because see right now nobody asked, because in third year only it will start the AIML. So you should also know, I am also writing down, so you should also common kernels. Yeah, again screen froze. Okay, let's try it some color like this. Oh man. Okay, leave this for right now, because if I change the page also it won't work. Again same thing. So just leave this for a minute, let it refresh. Till then if you have any kind of doubt you can ask. So there are mainly 4 types of kernel: linear, polynomial, RBF, sigmoid. Linear bole to works for linearly separable data. Polynomial bole to can handle curve boundaries. RBF, radial based function, popular for non-linear problems. This will not be required, but okay. Anybody have any kind of doubt till here? Do you guys understood what is a kernel, or you need explanation on kernel? For example, think of like this one. Think of this circle or the data point, whatever, if you are having x axis over here onto this, something like this. So it is not linearly separable on a plane, right? So what you can do, you can push it like, you can make it a curve. Think of like you're having a normal plate at your home, normal plate, and you want to punch in the center to make it curve. Although your mummy is gonna kill you at the end, but still you had a thought of doing something like this. So you had a training, you did like you grown your biceps and something like this, and you just hit into it. So how it will look like? Earlier it was a line, no? If you see it from the side view, you will see like something like this, right? But once you hit it, it will look like something. Uh, Instead of this straight line, this will now become like a curve, like a concave, right? So that's what we are trying to do. Whenever there is a straight line, we can push it into a curve, and then without doing too much of complications, we can find out what is the best fit line or best way to separate this, either a plane or something, right? Are you guys getting my point? If not, it's not necessary to understand every algorithm. If you know out 5 or 7 out of 10, 20, that is too good. But that knowing should be everything. Okay. And I'll encourage you to go with the SVM. It is such a good support vector machine. It is one of the important and good algorithm. Alright. So now the problem is solved. We can start. So there are 4 types of kernel: linear, polynomial, linear, polynomial, and then you have RBF, radial based. Sorry, radial basis. I'll write the full form. And the fourth one is sigmoid. Sigmoid is a good one. You will be encountering this multiple times. So, what is linear kernel means? Linear kernel is nothing for when your data is linearly separable. At that time, you are going to use linear kernel. When your data is linearly separable. Data. Polynomial. See, we know, no? Okay, if you are talking about x square or something, so if you plot x square 0 for 0, 1 for x1 is 1, for 2 it will be 4, for 3 it will be 9. So you'll get a curve. So to remember this, whenever there is a curve and you want to do model training using SVM, at that time you should use polynomial kernel. See, many people don't know which kernel to use when. Your data is polynomial. You had your PCA or TSNE plot. Okay. Or you just plotted your data and you saw that the data is this one, quadratically going. And you are putting linear regression into it, so it will give you very bad result, right? So that's why the basic knowledge is important. If your data is separated on a curve type or on a boundary, so at that time polynomial SVM kernel will be the best option for you, right? So can handle curved boundaries. RBF is nothing but radial basis क्या था यार basis function हाँ radial basis function. I'm yawning a lot. Explain. So RBF is mainly used for non-linear problem. You can write it. Non-linear बोले तो non-linear problem. I think it's one of the bottom part of this page. means what we had a top like this, no? Again, bottom. Something like this. If it is not linearly separable, so we are gonna use radial basis. Radial basis you can understand, no? Radial is nothing but like this. Radial by basis with basis. Basis function or Gaussian function. So yeah, that's it. No, if your data is something like this, and you want to separate it, you want not separate, you want to train the machine learning model. So at that time, you can post it inside, no, a punch, like your mummy is gonna punch on your face after seeing that thali, that plate. So similarly, if it is your data is radially distributed, at that time you are gonna use RDF. And the sigmoid is for neural network. So right now leave this part. Not required by not. Any doubt till here, guys? Any kind of doubt? Are you guys understanding or just saying no, no doubt? Okay, we'll talk about now the workflow. No, at that time you'll understand. How many of you understand SVM? Raise your hand. Out of 22, I'm watching only 8, 9, 10, not half also. Now half, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now everybody knows SVM. Okay. Okay, then go learn by your own. I will go sleep. Okay. So, uh, see, once we talk about workflow, no, you can understand. So, workflow. Over here, no, you can understand basically. What we are trying, we are selecting a kernel based on our data, and we are feeding it to our SVM support vector machine, and we are just checking for the parameters. What are we having? Like some parameters are also there. I'll tell you what. So based on that parameters, then we are going for the prediction, right? So the basic stuff is your data pre-processing and whatever you have. So the first one is data pre-processing or data processing event, right? How many of you want to drink tea right now or coffee? I need a coffee, else I'll sleep. If you need a coffee, put a thumbs up. Jayesh. Bro. Send me one more. No, I'm also yawning a lot. So first we do data processing. And once we are done with whatever data processing, ADA, feature engineering, blah blah blah, pre-processing, scaling features, labeling, encoding, whatever we have. Once you are done with this data pre-processing, then we are going to select the kernel for the SVM. So to select the kernel for the SVM, we just right now talked about which type of kernel is for what. For the linear, something is different. Polynomial is for something is different. Radial bias is for when your data is not linearly separable. And this one, sigmoid is for neural network. So we have to select the kernel based on our data, right? How we'll come to know? Again, EDA, exploitative data analysis, how your data is distributed. One thing is known as PCA, principal component analysis. Once you do PCA, no, at that time you can understand how your data is separated. Is it linear? Is it quadratic? Or is it what we say categorical basis or class basis or however whatever you want, you will get through the plotting of the data. Net PCA is for mainly feature selection, but you can use it for the plotting also, okay, how the features are distributed, right? So once you select the kernel, then you have to select the kernel, you have the data, now train the model, train SVM based on whatever the kernel you have selected, right? So it will find an hypothesis again, that is hyperplane hypothesis, and based on that hypothesis it will be creating a hyperplane, and based on hyperplane it is predicting that it is in a positive direction or it is in negative class, which class it belongs to. The negative is the left side, positive is on the right side. So it totally depends upon which type of slope you are having in your graph, right? negative, positive, positive, negative. So leave this part right now. So it will create an hypothesis. It will give you a hyperplane based on the hypothesis, hyperplane, right? And once you got the hyperplane, you have to fit your model based on it. Like you have to train on it. That is hyperplane is justified by the hypothesis whatever the data is having right now. Now once your model training is done, then you just have to do some parameter tuning. We call it fine tuning or parameter tuning. Both are same thing. Parameter tuning or fine tuning. Fine tuning SVM model, support vector machine model. So in that what we are some you can understand is regularization. One of the term which you can change and check for the output, that is regularization. Then again for the kernel now we are having something known as kernel parameter. Kernel parameters like how is the data, okay, what are the different types of distributions possible in net. So kernel parameters have multiple things which you can change and you can go for the more betterment of the result, right? And how you can do, so there is one technique known as cross validation. Okay, I have already given a brief of cross validation. If you can remember better, else once your parameter tuning is done, just predict the data, like final deploy or whatever you are gonna say. Okay, you can use it for classifying. Okay, so to visualize SVM on the 2D data, we use scatter plot. Again, taking from my notes only. Over it is written that imagine a scatter plot with two different types of dot. The SVM finds a line that best separates the red from the maximizing the distance of the closest red and blue dot. That is linear SVM. Linear SVM on two-dimensional data. They are doing work or they went home. Okay. So linear SVM, let's say again same thing what is written over here. What I gave the example. Let's say these are the two classes, cross and zeros. So it is telling that maximizing the distance between the closest this and closest this point and try to maximizing the distance, that is the margin. Finding a optimal margin such that the model can easily understand the distribution of your classes. That is the main whole reason, right? Then non-linear, if data are mixed such that no straight line works, at that time SVM use kernel function to bend the space and separate them with the curved boundaries. For example, have you tried putting one bucket in another bucket? Can you tell the fourth again? Yes, I can tell the fourth again. But have you ever tried putting one bucket inside another bucket? You can think of like this, no? If this is your one bucket and you're trying to put another bucket. So there is a curve. This is one of the curve. What we are trying to do is or see the better example. Let's say this is your room dustbin, right? And you want to put what we call a cloth of the dustbin, that black and white color one stuff, or polythene inside it. So for the dustbin you are gonna, but the cloth originally is a plain one. It come in the folded shape. So what you did, you just put your hand and you just inflated it, right? In a larger one, and you then started putting it inside this. The same thing, if your data is like not linearly separable, like cross, what we had, a circular one, you can't separate using a single line, right? So at that time, you just have to push it inside, like how we push this dustbin sheet. So it will be now on a curve, right? Means trying to do plotting of two-dimensional data on a three-dimensional data, 3D plane. That's it. When you plot your two-dimensional data in the 3D plane, at that time you will automatically start seeing the boundaries. So once you see the boundaries, this is one boundary. If you are trying to do anything, any prediction based on this, so you have to go through. Means instead of this, what we are having a linear one, now we are having a curve one. That's it. That's the difference. And that's why we are using the kernel. Right? So can you explain the fourth topic again? Parameter tuning. Parameter tuning is, you can understand like this. Let's see if you have Rolls Royce, or Jaypriya. Let's say you are having a Rolls Royce Phantom, or you are thinking to purchase it, right? Thinking to purchase a RR Phantom. So, if you are thinking to purchase this one, what you can do, you have to go to the showroom, right? Showroom. Over there, you are having a multiple cars, right, of different specifications, but still you choose a model. Let's say V8, V16 or V12 engine, whatever the specifications you need, V8 engine or whatever you want, at the Rolls Royce showroom. So you selected a car. So what is the feature of Rolls Royce? They will give you one thing, कि which color you want to choose, which type of color you want. Acha, you want doors to be open, like do you want an umbrella in your door or something like that, or if you want which speakers you want, which company speaker you want. Okay, after company with the speaker, do you want which type of क्या कहते हैं body relaxation techniques you want in your car. Okay, tell me the color of inside one. Do you want it to mix of 2 3 colors or something? Okay, do you want your signature on it, or whatever, multiple things are there. So customizing your car, choosing a color. Okay, they can ask you which type of yeah, wheel you are using, this alloy wheel or whatever, multiple things are there, I'm forgetting right now. Alloy wheels, and in that also 12-inch, I am forgetting a lot of things. So what type of wheels, and in between whatever they have, then color, then the one thing you got is the same engine, the same thing, the base model. Now you have to modify it. That is known as hyperparameter tuning. Same for the machine learning model. So you have machine learning model, one equation. Now what you want? You want, okay, instead of starting from the zero, okay, putting zero as your intercept in linear regression, we will try to put intercept at 2. Positive, sorry, 2 no, so that is in x-axis, so that is, sorry, y-axis, so that is over here. So the now line will go from 2. Right. So that is called hyperparameter tuning. Changing the model, some inputs based on the, which are not gonna change, like input. I'm sorry, my words got scrambled. Like I'm getting scrambled, my word is still fine. The point is to customize. The main word is to customize. If you have a laptop, if you want it to be painted, you have to go and paint it. If you want to upgrade your RAM, you go and upgrade your RAM. If you want to change the color, if you want to change the screen, if you want to change the battery, if you want to add something, if you want to add graphics card or something, that is called hyperparameter tuning for your laptop. Similarly, if you are changing some inbuilt things which doesn't change the working principle of your model, but it helps to adapt the data. That is hyperparameter tuning. Now you understand what is hyperparameter tuning. Everybody understand what is hyperparameter tuning. Yes. Only 1%. For everybody, 2% put thumbs up. That means yes. Now you can write 3 things. What? 4 things we can write. Okay, 4 things we have, then we will wind up today's session. Workflow we did, then important SVM points. Okay, let's start writing. Again, notes and notes only. Once we do the coding part, at that time you can understand more easily. But you should know how SVM is working, so such that if you are working on a real-time data set, at time you can understand. So if you have something like what we were talking about, I forgot. Important key points, important points you can, important points. Important points for the SVM. First, works well in high dimensional spaces. You can write works well in high dimensional You can put HD also, high dimensional spaces. The point is you should understand it's not high definition or something. It's a high dimension. High dimension. High dimensional spaces such as your text data, image data, or image recognition. Second key important point about SVM is it is effective when number of features are greater than number of samples. Leave this point right now, that is not important, but you can understand. See now, number of features means number of columns, how your model is depending upon what are the key points, okay. And number of samples, anybody, what are samples? Anybody can tell me what is samples? Anyone? Hey, you should tell guys. Training data, okay. Anybody else want to guess what is samples? Because multiple times we have talked about. You can unmute also. I'm on the screen watching you guys. Anybody? Maybe classes we are giving. No, that are features. No. Correct. No. Okay. One answer is this. Somebody was speaking something. Individual data you can call. Yes. Individual data. Or observations. Yes. This is also a good word. See, first answer was. Kya? I forgot. What was the first answer? Training data. Bro, training data is one of the part of samples. Training data. Whatever you have in your data frame, no? Whatever the data you have, whatever I'm talking, you are using for the machine learning practice, right? So any row will be called as sample. Any row, let it be your train or your test or whatever you are having, that will be samples. Or you can call it as instances also. At that time also I told you, instances, row and sample. Right? That is your training data. Now Akshay told maybe classes we are giving. The classes what you are giving is your target column classes, right? Target column classes. That is a different thing. Target column classes means either hard-based and DSM. That is not sample. Samples means if you want to try something, you ask for sample, right? The same way. If you want to use some product, you ask for sample. Or sample paper for mid-semester examination or semester end examination. That is also a sample paper. I mean, sample. Give me one of the piece of what it can be. The data, any row, each and every row will be called as sample. Number of samples greater than number of samples means your columns should be greater than rows. Indirectly what it is telling for the data. So this will be more effective. You guys understood? Do you guys understood the point? Put a thumbs up, no? Again, the third most important point is it is sensitive to feature scaling. We can talk about this how. See, if your data is distributed like this, I'll take this example, the left one. Let's say your data is distributed like this. Okay. Let's say Now you plotted a line, hyperplane, and you plotted the margin line, and over here you plotted the margin line. Now the concept is what I was teaching. I forgot. What I was teaching. Feature importance. feature importance, feature importance. So for the feature importance, why it is important? Okay, if you let's say this value is present at 12 comma 10, right? This value is present at 12, x-axis, no? So increase the x-axis by 14, y-axis nearly 1. Right. Same way, there is a multiple data, and if you do the scaling part, they will come to close to each other, right? So the radius of the outer value will be reduced. For example, logarithmic scaling, if you try to do, if your data is at 1024 and you do log base 2 transformation of 1024, that is nothing but 10. And now again we had a discuss about 64, that is nothing but anybody. Log 264 is 6. So 6 and 10 are now more close. Earlier, both the points 64 and 1024 were far, a lot far. But 6 and 10 are very near to each other. That's why if you do the scaling, SVM, every time, if you want to try training your model, try, try training machine learning model, your ML model, without scaling. Okay, and once you are done with this, try with scaling. You will see a huge क्या कहते हैं, jump in your accuracy. Huge. I'm talking about huge, not small. I'm talking about huge. Huge. Like if it is giving 80% something, at that time if you do the scaling part, it will become 88 or 87 easily. Again, see, if I'm quoting something, that means it totally depends upon your data. If data is already your 1, 2, 3, 4 and you're telling, bro, I did scaling but my accuracy from 80 went to 80.1 only. How I can trust you? You only taught us it will go 87. Bro, but in that case your data should have some major difference, 101, 150, or in fact you can go to 190. Now this is having a more difference. Now if you do the scaling part, yes, it will give you 83, like 3 to 4% increase. Are you guys understanding what I'm doing? Small data set? What small data set? Do you guys understood? If anybody have doubt, raise your hand. You can think like the support vectors, you can think like based on this only, the model makes the decision. You can think like this. For the classification purpose, model think like, okay, if this is point on this one of the margin and another point is at the another margin, so means it won't see this data. For every data, whatever the points coming inside this area, this will be your negative or positive, whatever, this cross area, like one class, one type of class. And it will take this support vector as another learning method, and everything after this line will be categorized as O or 0. You guys understood the importance of support vector? Okay then, we will continue forward with some basic use cases, and strengthen and limitation. That's it. 2 more topics, we will wind it up, because giving too much right now is not sufficient, like not needed. Learn that much only, how much you can digest. SVM use cases. And don't question me, bro, how are you digesting this much? Bro, have you seen my health? Why I'm this much fatty guy? Because of this only. So, if you want to become fatty like me, start doing whatever you are avoiding right now. Okay, you should eat around 10 to 12 parathas in a day. 2 to 3 kgs of rice. And maximum, I'm telling, maximum 1 kg of ghee. That's it. That is sufficient. And 1 month of consistency. You should not leave in between, right? How many of you are gonna follow this? You can raise your hand if you are gonna follow this. Okay. Sarah. Okay. Jayapura. Okay. Sidran. Okay. Akshay. Okay. Okay, guys. Let's continue with our part. Else, just for fun, I'm talking in between like this. Okay. So such that you should not also get bored of, because you are not watching me whatever I'm doing. You guys are also like Arnold. Something you told. ये कौन है? Who is this guy? Oh, brother. Oh, okay, okay. Arnold, I have heard of. But that second time I have heard. Nice. Bodybuilder. Yes, 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 yes. Okay, bro. We should study. We should not talk about movies and dieting part. Else somebody will come and tell me, "Hey," while I will circulate my feedback from no, he will put, "Okay, Bhaiya was talking about teaching about how to gain weight, how to lose weight, how to excel in uh, film industry, but he was not teaching us in learning." So I have to think a lot ahead. So SVM use cases are, first one is text categorization, then spam detection. Because if this is a regression one, if this is a classification one, you can use in both spam और क्या कहते हैं detection, image classification. Again, guys, you should not mug it up any of the thing. As soon as you are gonna work hard and hard and hard, build projects, multiple projects on multiple algorithm, you'll come to know which one is the best one. Bioinformatics, credit risk analysis, medical diagnosis, then if somebody asks, can SVM be used for your neural net or deep learning neural network? Yes. Handwritten, handwriting recognition, yes, and blah 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 blah. Again, the last topic, strengths and limitation. Or you can do one more topic, no? SVM practices. What you can do in SVM practices, first thing, you should always scale feature based on the nature. Based on the requirement, you can go for the scaling, because this is one of the feature which increases the SVM result. Scaling features. Standard scaler, min max scaler, logarithmic scaler, a lot of things are there, you can go and check. Parameter tuning. Or you can tell ke how to improve accuracy of it. These are the methods you can use. Parameter tuning, handling imbalanced data. What is imbalanced data? I'm telling you guys, there was no. See, at my time there was nobody who was teaching like this. If I got a person like me, no, I can't tell how happy I am. Handling missing imbalanced data. Then fourth part is के क्या है? Assume how to probably just the counter leave the fourth one, it's not required, right? So these are the three things which you can do to improve your accuracy. What is handling imbalanced data? For example, we have a data set of heart patients, right? Over there, what we are having, out of 100, 80 are patients in our data set. In our data set, I'm talking. 80 are patients, 20 are healthy persons, right? So what is the case? When you are training your model on this data set, your model will be biased towards the 80 because model have seen more this type of cases, less of this type of cases. So to avoid this problem, what we do, we always try to have the balance of the data, handling imbalanced data. Balance and imbalance means this only. If your data set have this much of imbalance, what is the ratio? 8:2. So try to come between 4 to 6 is also fine. 5 to 5 is the best. Try to put on 5 to 5 and 4 to 6 or 6 to 6, the same thing. Right. You can go for this also. 5.7 is also good with respect to 4.3. This is also good. But actually nearly equal. That is known as handling imbalanced data set. You guys understood what is handling imbalanced data set? Right now you should not need to worry about how to handle because there are multiple techniques. Singularity, minority, class generation. A lot of things are there, guys. A lot. Right now what you are seeing is just 1%. Like I'll tell 1% is too much. 0.1% of machine learning. Okay. Did you guys understood the concept of today's class? Okay. And do one more thing, guys. Everybody, do one more thing. Go to the hcf.org.in, give your review if you have not given. Because your review is the real thing which you are directly uploading over there. So I need your review. Okay. See, if you're gonna put something good, it's fine. If you're gonna put something bad, do let me know first. Joking, you can put anything, whatever you want. But the point is, it should be truth. Alright. The last topic, and we'll be ending up our class of SVM. Basic topic, strengths and limitation. Strengths versus limitations of what? SVM. See, there is a lord whose name is Andrew Ng, machine learning lord, right? So what I'm trying to do, I'm not क्या कहता हूँ मैं कभी कर भी नहीं पाऊँगा, I can't beat him. But the point is कि I never can't beat him. So the point is कि this guy is the best guy whom I have ever seen who knows machine learning. Right. He's one of the major focus which I have always seen is in the people selecting the model. People selecting models. Most of the people, guys, I'm talking about 95% of the machine learning engineers don't know which machine model. 98, make it 98. 98% of the machine learning model engineers don't know which machine learning model is good for their data set. So this is one of the key important thing you should be knowing. And how you will come to know? First, you should know about every model, the main model. And secondary thing, you should know about your data. The more you explore your data, the more you find the dependence, the more you find the relation, the more you find the distribution and everything, the data pre-processing technique, the best you can find, the best model you can choose for your data. Right now, while I'm also teaching, I'm holding a lot of things to tell you guys. Right now, when it comes for the imbalancing data, there are multiple ways. For textual data, it is different. For image data, it is different. For your normal machine learning model, if you're trying to deploy at that time, generation is different. But there is no way of teaching this. Like, it is not meaningful if I teach you that. So only one request: never stop learning. Keep on learning. Keep on understanding things. This is my like not request but order you should be following throughout your life. Right? No, I should request you. I am talking about your benefit, so I should order. I should not request. Okay. So effective in high dimension. High dimension. Then it can work for both your linear and non-linear data set. So can model both linear and non-linear data set. Can model both linear and non-linear data. Only support vectors. Only support vectors defines the model. Then I'm just writing whatever is there in my notes and I'll explain that. Generally opposed to overfitting. Right. Generally, not always. Generally. Not suitable for very large data. Very large I'm talking. Large is fine. Not suitable. Very large means you are having 300, 400 columns, 2-3 lakhs of the rows. At that time, it will take a lot of time to figure out the dependency and everything. So, the less the features, the less the sample, the better your model. The more the features, the more the sample, the more data preprocessing you should do. See, people what they think, no, okay, if I give my model more data, means at a time in my second sim, I was also thinking the same way. The more the data I feed to my model, the more better it will become. No. This is not the case. Okay, so you should also not think like this way. The more the data, the more better it will be. This is not the case. You'll come to know. So slowly, sulpa, you'll come to know. Not suitable for very large data set. Data set, DS is data set. Then computationally expensive. Does not perform well with significant noise. Why? Because it is too much sensitive to the scaling part. So if there is a noise, too much of noise in the data, means this algorithm is gonna learn that noise also. So does not perform well with significant noise. Right, brother. Less interpretable. Why this is doing more like this? You can't interpret it at the everything. Interpretable. Then tree based. Decision tree is one of the algorithm we'll talk about tomorrow. Tree based methods. Do you guys understood? So we are gonna close our class today over here. So any doubt till here? Any feedback you want to share? Anything you want to tell us? See, soon our course is gonna over. Only 14 days, 2 week more, and you will be having क्या कहते हैं ceremony. What do you call that ceremony? Farewell ceremony. So if you have anything you want me to improve, just let me know right now. Because right now is the teaching part. Once it is completed, then we will be scaling too fast on the projects using all this algorithm. You are thinking like I am just doing the क्या कहते हैं theory part. No, I am not doing the coding part. Guys, wait. How much project you have done in the 2025 in related to machine learning, you will gonna do more than that within upcoming 2 weeks. I can guarantee you. I can bet on it. If you have done 20, more than that, we are gonna do it. So just wait and watch, brother. कहते हैं ना, you should know what you are gonna do. If you don't know, if I give you the code, okay, this is how SVM is loaded, this is how naive Bayes is loaded. I tried in linear regression, but then I felt like you will forget once I'll complete it. No, You'll forget at the end when we are talking about multiple models. So that's why I'm not doing. So just understand the concept right now. Do revision daily, and as we will be completing our this thing now, you will be smashed with projects, brother. Don't worry. My work is little now getting reduced day by day. Right. Some of the housework was also there. That is around 80% completed today. So once I'm free with this, I'm gonna wait and watch. Okay. At that time, like on a particular model, I'm gonna do bare minimum 3 to 4 projects, and we are gonna talk about 5 to 7 machine learning models. So 7 into 3 is 21. How many of you have done more than 21 machine learning projects this year? Raise your hand. Frankly, I'm talking frankly. If you have done, raise your hand. It's not a challenge. It's more like a competition. The क्या कहते हैं ना उसको positive competition. If you have done 21, we'll go for 25. If you have done 25, we'll go for 30. You guys understood? Don't take it negative way कि Amitabh has ego or something. I don't have ego. I am too grounded person if you know me very well. Okay. So, okay guys. If you have any doubt, you can stay, else you can leave. If you want to share the feedback also, you can share the feedback. Okay. Else you can leave if today class is over. Jayesh, are you there in the class? He left. Okay. Hi, brother. Thank for your hard work making us to learn. Yeah. See, you're welcome, Akshay. Jayesh, how did you understand the concept of SVM? How was it? And for the linear regression? Because you told no, you have just scrolling through it, and that's why I asked you. You know a little bit of it, so I thought you will be the better person to like assess it. So okay, brother, that was like making me confident. That's for that only I thought. You're not well, right? Your voice is. Okay, that complete that phone pay part today, no? That client ID is there in the developer setting. Okay, brother, I'll talk to rest of the class. If you have, guys, if you have any kind of doubt, you can ask. No. See, me and Jays are two good friends, right? That's why. Okay, you only thanks give 500 to him. Huh? Why you only thanks give 500? Okay, I'll give 500 to him. To Akshay? Acha. Means I have to pay money now. Okay. Okay, brother, I'm gonna teach you, I'm gonna pay you. Nice, huh? Very good. Nice. Bankrupt हो जाऊंगा मैं, मेरी प्रॉपर्टी बिक जाएगी. I'll come to the road. Okay, अल्लाह के नाम पे दे दे, something like that I have to do. Okay. I see in text it's not clear. Okay, guys, you can leave, and if you have any doubt, you can ask. Bye, brother. Bye. Hello. Yes, clearly. 500 rupees. I wrote what I wrote. I forgot. Not here, right? Above. This one, no? Parameter tuning one. Find. Regularization. Yes. And kernel. I forgot. कुछ तो है ये कर्नल पेथ आई डोंट नो आई फॉरगॉट आई हैव टू चेक